Great. It's recording now. So let's talk about this section 3.9, derivatives of exponential and logarithmic functions. Welcome, Oscar. I hope you're doing well. We just started. Okay, and in order to talk about the derivatives of exponential and logarithmic functions, let me remind you about this exponential function. This is a special exponential function, I would say, which is called the natural exponential function. Why is called the natural exponential function? Because of its base. Its base is E, Euler's number, right? Euler's number is a special base. So this is a special function, f of x equal e to the x. We are going to get a formula for the derivative of this special function, okay? But first, let's just recall that this function, when graphed, meets the y-axis at this point is 0, 1, right? That's the y-intercept. And then it's increasing from left to right, right? Increasing. Now, the value of the base E is approximately equal to 2.718. That is called the Euler's number. Now we're doing calculus, so we have to figure out a way to take the derivative of this natural exponential function, right? So we're gonna do this now. So suppose you call f of x equal e raised to x, natural exponential function. So if you want to find its derivative, follow the definition of the derivatives using limits, that would be the limit as h approaches 0 of f of x plus h minus f of x all divided by h, right? That is how we define the derivative, right, for any function. So now, but what is f of x plus h if our function f of x is equal to e to the x? Well, this is the input value, right? So we're gonna replace that for x, and we will have this e raised to x plus h, that will be f of x plus h, minus f of x, the function itself, e to the x, right? And all divided by h. And we are supposed to take the limit as h approaches 0 of this expression, which is called the difference quotient, right? Applied to this natural exponential function. Okay, now in order to go through this computation, I'm going to rewrite this e raised to x plus h as e raised to x times e raised to h. Turns out e raised to x times e raised to h, since the bases are the same of these two powers, is just equal to this, right? I'm writing this in this form because next I want to factor out e to the x, right? Very good. So next, well, what's going to happen here? Well, if we factor out e to the x, notice this e to the x are the same, right? We factor out these two guys. E to the x outside. What is left inside? E to the x into e to the x times e to the h is just, after canceling these two, e raised to h minus e to the x into itself is just 1, right? 1. You may say, Professor, why are you factoring out e to the x? Well, I'm trying to separate this term containing x from this term containing h, right? You will see next why. Once you factor out e to the x, notice the following. Notice that we can distribute our limit over this multiplication, right? Over this multiplication. E to the x times this, right? Times this. It's a multiplication. So I'm going to distribute my limit over that multiplication. We'll see. So this will be limit of e to the x, right? This guy, times the limit of all this part, look, e to the h minus 1 over h, right? And both limits as h approaches 0, right? So h approaches 0. I just distributed the limit, right? Maybe I can put arrows here to indicate that. But now, notice, guys, that this limit of e to the x as h approaches 0 is easy to compute. E to the x behaves as a constant function with respect to the variable h, okay? Again, x with respect to h is just like a constant. So the limit of a constant, remember, is just the same constant, right? So this limit, easy to compute, is just e to the x. Now, for this limit, I have to figure out how to get it, right? How to get it. And remember, I show you in order to compute limits, we can use tables. So we're gonna use tables to compute this limit. All right, so remember h approaches 0. So if you approach 0 from the right, I can take real numbers very close to 0 from the right here. And if you approach 0 from the left, I can take numbers very close to 0 from the left, right? I can do computations here, output values, and see if the output values, they converge, right, to some real number. So let's do that together. So bringing out our scientific calculator, our decimal scientific calculator, let's do the computation. E raised to h minus 1 over h. Where is e to the x, Professor? Well, you can type just e, or you can use the function notation here, e raised to h minus 1 over h. But h is 0.01, right, for the first computation. So 0.01 on the exponent minus 1. And this whole thing, I'm going to highlight, then press slash, must be divided by h 0.01, right? 0.1. What do we get? We get this guy, 1.00501. Now, the next computation is very similar to this. So what I'm going to do is this. I'm going to copy and paste this here. And the only thing I will change is this. I'm going to add a 0 to this input value, right? Look, this has an extra 0. It's closer to 0, right, than the previous input value. But now look at the computation, gives me this, right? Gives me this. 1.0005001. Now I need to do computations for negative values close to 0, right? Now, for this computation, I notice it's very similar to this. Copy, paste. And all I have to change here on the input value is this negative sign, right? Negative here, and I am getting the output value associated to this input value, right? This goes here. Look, I got 0.999, so on. The last computation is very similar to this. So I'm going to copy and paste this. So we do this efficiently, right? And I just have to remove 1 0, right? Look, the only difference between these two is 1 0 less here after the decimal point, right? So just remove 1 0 here, 1 0 here. And there you have the answer. Now, notice this guy. Make it bigger. These are the 4 results, right? I'm going to write them down here, 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 and here. And we are going to figure out what number or what real number these values are sandwiching. While I write this out, try to figure out what number you are approaching output-wise, right? Try to figure that out. All right, so I'm going to copy these 4 results here. And then I invite you guys to tell me where these output values are approaching from the left and from the right. If you are good at figuring things out, give it a shot. Try to tell me where these guys are going from the right, where these guys are going from the left. I see a couple of answers from students. Very good. Oscar. Yeah, you made my day. Adriana also, right? Of course, 1, right? 1. is the number that is kind of being sandwiched here, right? And this word, informal word sandwich, serves the purpose to say, right, that from the right, you're going to 1. From the left, you're going to 1. So the limit of this e raised to h minus 1 over h as h approaches simultaneously from the left and from the right must be 1, right? Must be 1. I'm gonna highlight this sort of to justify what I'm gonna write here. 1. All right, so now, but what is e to the x times 1? Well, e to the x times 1 is just e to the x, right? E to the x. Great. So this is telling me that the derivative of this function f of x, e to the x, is just itself, right? Itself, amazing fact, right? It's itself. Yeah, e to the x. Right? We proved this formally, right? Using the definitions via limits, and turns out the derivative of the function f of x equal e to the x, natural exponential function, is itself. So from now on, guys, when they ask you to take the derivative of the function e to the x, where e is Euler's number, right? You will answer with this. This is equal to e to the x. That's it, right? Easy to memorize, right? And that is probably why in mathematics, when mathematicians work in calculus, they consider this function to be the nicest function in calculus, because its derivative, it's itself, right? You cannot miss that, right? Derivative of e to the x, itself, e to the x. Very good. Now, this is the derivative of e to the x in its basic form, right? In basic form, exponent x. But turns out you're going to be asked to compute the derivative of e to the x squared, e to the 3x plus 1, e to the sine of x. This may be a function, right? Remember, we are dealing now, since we know the chain rule, with composite functions. So in general, using the chain rule, when you are asked to take the derivative of e raised to some function g of x, what you're going to do is the following. You will say, okay, derivative of the outside function is this, but then I have to multiply it by the derivative of the inside function, right? G prime of x, okay? So this is in general what you have to do. When the exponent is some function of x, you take first e raised to g of x, but then you multiply by the derivative of g of x, because turns out for exponential functions, the exponent, or what appears on the exponent, is the inside function, okay? Yeah, so this is what we will do in general. So I hope you will remember this, guys. Okay, so first result is this. So now let's see how we can apply this result to exercises. Example 1, suppose they ask you to take the derivative of this function 2 times e to the x. Let's start with something simple, and little by little we will go over something more challenging, right? So what should be the derivative of this function 2 times e to the x with respect to x? Well, notice that this number 2 is just a constant that I can take outside my derivative, right? And I can just focus on taking the derivative of e to the x, right? But what is the derivative of e to the x? Anybody could tell us in the chat or verbally? What is this derivative of e to the x? Great. Remember, e to the x is the nicest function in calculus. Is itself, Oscar, yeah, you made my day. Derivative of e to the x, guys, itself, believe it or not, e to the x, right? And then that's it, 2 times e to the x. Very good. Very basic example. Let's go over example 2 now. Suppose now they give you something like this. Compute the derivative of y equal a times e raised to negative 6x. Solution. Well, here we start by writing out our function here, y equal 8e raised to negative 6x, right? But now, since this is a composite function, we should identify our outside function or inside function. But even before that, recognize this number 8 as a constant. This number 8 is just a constant, so we're gonna take it outside the derivative, okay? So the derivative of y with respect to x will be equal to 8 outside, and we just focus on taking the derivative of this guy, e raised to minus 6x with respect to x, the derivative, right? That's it. Okay, great. So 8 outside, this derivative. Now, for this derivative, guys, I want you to think of these exponential functions as follows. E raised to something. And this e raised to something should be considered to be your outside function, okay? Outside function. And this minus 6x, this should be considered to be your inside function. Sometimes students are puzzled when I do this with exponential function, so I'm gonna write it here for you. Inside function, the exponent, what appears on the exponent, that is the inside function. And the exponential function, e raised to something, this is the outside function. All right, this is how this works. Outside function. Very good. Okay, so now start by taking a derivative of the outside function, e raised to something. That is basically itself, right? Itself. But remember the chain rule says here you must keep the inside function, not x, but negative 6x, right? And then you multiply this by the derivative of your inside function, right? Very good. So now this will be equal to what? 8e raised to negative 6x times, anyone could tell me what's this derivative? Derivative of negative 6x?
Negative 6.
Negative 6, excellent. Very good, Adina, very good. Negative 6, right? Negative 6, excellent, excellent. Now we have to combine or multiply these two guys. 8 times negative 6, that will give me a negative 48, right? Negative 48. And then e raised to parentheses negative 6. But remember, mathematicians, when they don't need parentheses anymore, they drop them, right? So most likely this is what you will see as your final answer, right? But moreover, mathematicians often have issues with negative exponents, right? They don't like to see negative exponents as part of final answers. So not a surprise, you might find your final answer on the multiple choices like this. Minus 48 divided by e raised to 6x, okay? Be aware of this, guys. Now, moreover, the negative signs, mathematicians often put it in the middle, right? Not on the top, not on the bottom, but in the middle, aligned with this. Yeah, so this is what most likely you will see on your multiple choices. When you take your exams, when you work on your worksheet, this is what you will see, right? For the homework, doesn't matter if you try this like this or like this, your answer, Weber will take both. But for identification of the answers within the multiple choices, this is the one you should use. Very good. Now, before we go over a situation with the multiplication of the functions, let me ask you to do some work on the worksheet, okay? So I want you to try the first one here, this one. Can you try this? They want you to find the derivative, right? F of x is equal to... Yeah, CG, you want to say something? Yeah, okay, great. Yeah, guys, in case there is background noise, I will mute you or you can mute yourself too, right? Very good. So compute this derivative, guys, and hint, try to see this as a constant, right? Try to see this as a constant. Rudy, welcome, right? This is X. Try to see this as a constant, and number 3 is gonna come out. And this E hint should be seen as the outside function. This 8x should be seen as your inside function, right? That number 3, don't worry about that. It should come out. It should come out. So go ahead and figure out the derivative, right? Figure out the derivative. Very good derivative. Doable exercise. I see 2 students already did this. Adriana, Oscar, let me double check. Okay. Very good, very good, excellent. Yeah, not that hard, right? Yeah, not that hard. Because remember, guys, e to the x, the natural exponential function, the nicest function in calculus, derivatives of e to the x itself. All right, great. So let's do it together, right? If you want the derivative of f, you gotta take 3 out and focus on taking the derivative with respect to x of this function, e raised to 8x, right? But we explained that when you deal with the exponential function, having an exponent, not x, but let's say 8x, some other function, right? We know that since this is our outside function, e raised to something, and this is our inside function, a times x, all we're gonna do is this, derivative of the outside function itself, right? Itself, but evaluated at the inside function, right? That's what the chain rule says. And then times the derivative of this guy, right? 8x with respect to x. But that derivative is just 8, right? 8. And putting everything together, times 8, 8 times 3, 24, 24, right? E raised to 8x. Exponent is positive, so I leave this alone. And there we have our answer, right? Excellent, guys. Excellent. Very good, very good. Yeah, the second exercise deals with a product. So let's figure that out. But before we do that, probably we can try this other form. This other form that I'm going to show you here with a composition of trigonometric function and exponential function. So what do you mean? Composition of trigonometric functions and exponential functions. Yeah, let me give you this as an example number 4, and then I will ask you to do number 5, which is similar, okay? So let me show you this. If they ask you to figure out the derivative of a function, a composite function that looks like this, cosine of, I'm going to write parentheses here, e raised to 5 times x, right? If they ask you to do this, well, don't panic, just simply recognize that it's a composite function, right? And identify clearly your outside function, which is clearly cosine, right, of something. And your inside function, this time the inside function is this guy, right? E raised to 5 raised to x. But you will see something there in a way, I will show you. So the derivative of this function, this composite function, will be, you start with the derivative of the outside function, derivative of cosine. But the derivative of cosine, remember, is minus sine, right? Minus sine of something. But that something is this, e raised to 5x. But then you're supposed to multiply this by the derivative with respect to x of the inside function, right? But turns out the inside function is itself a composite function, right? A composite function, not a problem, because we know how to deal with it, right? Again, this is the outside function. This is the new inside function. So this will become the following: minus sine of e raised to 5 times x multiplied by this derivative. Derivative of outside function, e raised to something itself, right? But evaluated at the inside function multiplied by the derivative of your inside function 5x. But the derivative of 5x is just 5, right? 5. So bottom line, finally, use this minus sine of e raised to 5x times e raised to 5x. When you no longer need the parentheses, drop them, right? This derivative is just 5, right? Times 5. But now what I'm going to do is I'm going to multiply 5 times -1, which is up front here. That is going to give me a -5, right? Then sine of e raised to 5x times e raised to 5x, okay? Now, one thing that mathematicians do, I explained already, right, is this very often. They place the simple functions composite wise, right, kind of first. So this one, e raised to 5x should go up front, and the sine of e raised to 5x should follow, right? Should follow. This is just a mathematical way to represent this function. So should follow, and that's it. Basically, that's it. Just do this. And the answer, therefore, should be, if you look through on number 4, is the first one, right? This -5 e raised to 5x times sine of this. Notice they have dropped the parentheses because they are no longer needed, right? So that's it. Now, following this, guys, can you try this? This one, number 5, this one. F of x equals sine. I'm going to write it nicely for you here, parentheses, 4e raised to twice x. Can you try this? And as a hint, I got to tell you this. This should be considered to be your outside function, sine now, and your inside function should be this. Okay, give it a try. See if we can do it. You're going to need this for your homework. Mm-hmm. 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 Welcome all you guys who just joined. We're working with the derivative of the natural exponential function. Very good, very good. For number 5. Excellent. Adriana, very good. Grace, Oscar, Adriana. Very good, guys. Very good, very good, very good. Excellent. Great, right? What will be the derivative of this composite function, sine of 4 times e raised to twice x? Remember, guys, mathematicians very often drop parentheses, but you can write them so that it will be easier to identify what is your outside function, what is your inside function, right? Helps. Derivative of outside function, derivative of sine. You will start with that, right? The derivative of the outside function, cosine, right? Derivative of sine, cosine of something. Well, something is your inside function. times the derivative of your inside function. So we're going to write this here, derivative with respect to x of this, 4 times e raised to twice x. Okay, the derivative of the function f should be cosine of 4e raised to 2x. This derivative, notice 4 is just a constant, comes out. So we are left with a derivative of this guy, right? Good, right? So then what should be this derivative? Let's see. And if you're not used to doing these things, guys, I recommend that you do this step by step. Look, this guy done, right? Cosine of 4e raised to twice x. This guy is a number 4. And this derivative, considering this to be your outside function, e raised to something, right? And this twice x, your inside function, right? Not x is twice x. Then the derivative will be derivative of the outside function itself, right? E raised to something. But here we should write as exponent the inside function, right? It's the derivative of the outside function evaluated at the inside function times the derivative of this function, right? But the derivative of 2x is just 2, right? It's just 2. Let's just write it straight, 2. That's it. Then just multiply 4 times 2, that is an 8, right? And that 8, write it up front, right? Up front. Remember the simple functions such as constant functions up front, right? 8. Then we must follow 8 with this e raised to twice x, which is this guy, right? And then in the end, push it to the right, the functions that look more complicated, composite wise, right? Composite wise. This would be a good presentation for the final answer, right? Excellent, guys. Yeah, and notice, right, in the end, mathematicians drop the parentheses, but it's this, right? Yeah, very good. Okay, now one more of this type, and then we will move on, okay? We will move on. One more of this type, so we can move on. Yeah, let's go over this. Here, I saw it somewhere here. This one, can you try this? It's a little bit tricky, but I think you can handle it. They are asking you to figure out the derivative of this function, sine of, I'm going to write within parentheses, e raised to minus theta raised to the third power, like this. Okay, and the hint is going to be take this sine of something to be your outside function and take this e raised to minus theta cubed as your inside function, and proceed, use the chain rule, right? Derivative here. Yeah, go ahead and let us know if you figure this out. And this natural exponential function, guys, let me tell you, it's a function that you will see a lot if you study science, in physics, in biology. It appears everywhere in nature. So it's important to know how to figure out its instantaneous rate of change, right? Yeah. All right, so let's see. See, yeah, it's tricky. I don't say that it's trivial. This one is tricky. Sarah, Oscar, let me see. Sarah, you got it. Adriana, yeah, Oscar, I think you need to adjust something there. Yeah, Adriana also, now good. Very good, guys. It's a tricky problem. Yeah, and this time, for some reason, they didn't put this down. They just left this alone, the e raised to negative exponent. But let's see together how this should be done. All right, first we start by taking the derivative of the outsidemost function, which is sine, right? Sine. The derivative of sine we know is cosine, right? Cosine of something. That something is the inside function following the chain rule, right? But then the chain rule says it doesn't end there. You have to multiply this by the derivative with respect to theta of your inside function, right? We will do it later. Yeah, this is what we're gonna do next. So y prime, the derivative of this composite function y is equal to cosine of e raised to negative theta raised to the third power. Okay, and I'm going to use big parentheses here, times this derivative. But in order to get this derivative, notice, guys, that this function is itself a composite function, right? Is e raised to something composed with this minus theta cubic function, right? So let's take the derivative. Derivative of this composite function is, we start with the derivative of the outside function, which is itself, but evaluated at the inside function, right? Evaluated at this guy, times the derivative with respect to theta of your inside function, which is minus theta cube, right? Minus theta cube. So let's put everything together here. Look, y prime should be equal to cosine of e raised to minus theta cubed multiplied by e raised to minus theta cubed. I'm dropping the parentheses here, times this derivative. But what is this derivative? Any guy could tell us what is this derivative? The derivative of theta cubed with respect to theta.
Minus 2 theta squared.
Minus 3 theta squared. Excellent, excellent, Adriana. Very good, excellent. You got it. Very good, excellent. So this is the just that, right? So yeah, we just took it. Very good. Someone wrote it also here. Very good, guys. Very good. Yeah, yes, tune. Yeah, very good, Sarah. Very good. Yeah, so then in the end, you just put this together, right? And try to follow this rule, guys. The simple stuff, simple functions such as this quadratic function, right? Put them up front. This is how mathematicians write the answers 99% of the time, right? Next, we're gonna write the perhaps this function, right? Right. That's right. Let's see if this works. And then times the cosine of e raised to minus theta cube. That's it. That's number 7. And this is a perfect match with this, right? Minus 3 theta squared e raised to minus theta cube times cosine of this guy. They drop the parentheses here. Excellent, excellent, guys. Very good. So we're good with this form. So now let me tell you what to do if we encounter this other form, multiplications of functions. And one of the functions is the natural exponential function, or a composition of the natural exponential function with some other function.
Yes.
For example, this or this, right? This or this, this or this, guys, right? So let me show you an example so you can deal with this, right? Very good, very good. All right, so this is gonna be here. What to do if they ask you to take the derivative of a function that looks like this: 5x squared times e raised to minus x. E raised to minus x. How you proceed? Well, you see there a multiplication of two functions, right? So a natural strategy should say, okay, let's use the product rule, right? Product rule. Recall that the derivative of f times g is equal to f prime g plus g prime f, right? G prime f. So let's call this guy f, let's call this guy g, and let's apply our product rule, right? Our product rule. So then we have to say that h prime, the derivative of the function h here, which is the multiplication of these functions, is start with the derivative of the first function here, 5x squared. That derivative is going to be 2 coming down multiplying 5, 10, right? 10x, right? 10x. Then the product rule says multiply that by the function g, by this guy, e raised to minus x. Plus, right? Plus. Derivative of g function, derivative of this function, right? What is that? Well, notice that this function e raised to minus x is just this, right? E raised to minus x, and minus x can be considered to be as our inside function, right? So we're gonna go like this. Derivative of the outside function, e to the x, or e to something raised to something, is just this, right? But that must be evaluated at the inside function, right? That's what the chain rule says, times derivative of this guy, right? Derivative of this minus x, but the derivative of minus x is just minus 1, right? Minus 1. That's it. Yeah, so we got it. But that's just the derivative of this. I need to multiply that by f, by this guy, right? So let's do it next. So times 5x squared. This is all. All right. So now let's try to simplify this as much as we can. This is going to be just 10x multiplied by e raised to minus x. This minus 1 times 5x squared is minus 5x squared times e raised to minus x, right? Now, notice, guys, that this e raised to minus x and this e raised to minus x are the same, right? Which means that we can factor out that. But not only that, notice that here, x raised to the first power, x raised to the second power, x is repeated too, right? There is a greatest common factor, or greatest common divisor, also called greatest common factor, is going to be what? X to the first power, x to the second power. You always take the one having the smallest exponent. Smallest exponent, right? Smallest exponent. Okay. And then for these two, since they are the same, you just take this itself, e raised to negative x. We're going to factor that out. So finally, h prime of x should be equal to x times e raised to minus x outside, parentheses here, and inside what? This guy into this guy is what? This guy into this guy, x cancels x, e to the minus x cancels e to the minus x, just 10 stays, right? 10 there. But moreover, look, I think I should have done this once and for all. Look, 5 and 10, greatest common factor, isn't it 5? So 5, right? 5 should have been here, 5. Yeah, so 5 out. 5x e raised to minus x into 10x e raised to minus x. 5 into 10 is 2. Now better. X into x, 1. E raised to minus x into itself, e raised to minus x, 1. Minus, minus. This guy into this guy, 5 into 5, 1. X into x squared is x, right? And e to the x into e to the x is 1. So this is it, right? Let's shorten this. We don't need this anymore. This is your answer in factor form. Now, sometimes I explain, right? Mathematicians, when they post answers, especially as multiple choices, they are annoyed by these negative exponents. So very often they bring it down. Whenever the result contains negative exponents, they bring it down so that this guy becomes 1 over e to the x, multiplying 2 minus x. And finally, you can say that your final answer is 5x times 1, 5x, times 2 minus x, right? Over e to the x. Most likely for multiple choice questions, this is the way they will present the answer, right? But for homework questions, you can type this in or type this in or this, the same, right? Equivalent. So Webwork will take it, right? Very good. Okay, so this is what you do, guys, when you deal with multiplications of functions, okay? Multiplications of functions. So I want you to practice here now. I want to practice. It's a nice exercise. Can you try this? Very similar to the one that we just did. Yeah, very similar. Yeah, try this, practice. G of x is equal to 3 times x squared multiplied by e raised to minus x. Hint, identify this with the function f, right? Call this f and call this your g. If the g here causes confusion with this, maybe you can use h, right? And recall that the product rule says that a multiplied by h when differentiated gives us derivative of f, derivative of the first one times the second one, plus derivative of the second one times the first one, right? That's it. So use this, figure this out, guys. Very good, very good, very good. Yeah, give it a shot, give it a shot. If similar questions will appear on your homework, so it's the moment to kind of learn the strategies, right? So that when you are there on your own, you can handle it. And also, I think these questions are well fitted for exams, right? They're not that long. Yeah, try. And don't forget to factor at the end. That's the key in order to find the answer, okay? Factorization is needed at the end. Aha, I see. For number 2, check. Number 2. Very good. Excellent, guys. Yeah, you got it. Oscar, Grace, Adriana. Very good, guys. Very good. Excellent. Good work. Good work. Yeah, practice makes the master, right? Yeah, so let's do it together so we can take our first break. The function is the multiplication of two functions, so we apply our product rule. To start with the derivative of the first function, 3x squared, that's gonna be just 2 coming down multiplying 3, 6. X raised to 1 less 1, I don't have to write a 1, right? Times the other function, in this case the function h, e raised to minus x, right? Plus here, the derivative of this function. But remember the derivative of this function, since it's a composite function, is not e to the x, right? It's e raised to minus x. So you're gonna see this as this function, e raised to minus x. Inside function, the exponent, outside function, e raised to something, right? So the derivative of that will be e raised to something, but that something is the inside function, times the derivative of this inside function. But the derivative of this inside function is just the number -1, right? -1. So let's write it there. Now, notice this is just the derivative of this guy. Still, you have to multiply by the other function as it is, right? 3x squared. So I'm gonna write here 3x squared. All right, good. So derivative of g will be equal to 6x e raised to minus x. This -1 times 3 is minus 3 x squared. I'm going to write that stuff up front. the complicated stuff following, right? So this way, and this was here, this is here. All right, but now mathematicians like to factor out what it's called the greatest common factor, right? Greatest common factor. But what should be the greatest common factor? For that, you have to look at the stuff that is repeated. For example, this is repeated. Definitely, it should be part of the greatest common factor. Also, X is repeated. Yeah, I see. Yeah, and 6 and 3, the greatest common factor is just 3, or greatest common divisor, also called, right? Sarah. Very good, Sarah. You got it. Yeah, very good. Excellent. We're headed there. So look, greatest common factor of 6 and 3 is 3, right? 3. So 3. Then for x squared, you take the one with this having the smallest exponent always for variables, right? For powers, that's the rule. X, right? X. And then for e raised to minus x, since they are the same, you just write e raised to minus x, right? Yeah, great. Let me highlight this so nobody gets confused. This is this guy, right? Yeah. All right, and now this into the first term. 3 into 6 is 2, right? X into x cancels, right? 1. E to the x into e to the x cancels 1, right? Good, just 2. Minus. This guy into this guy, 3 into 3, 1. I don't have to write the 1. X into x squared, x there, right? And then e to the minus x into e to the minus x is 1. So this is it, right? This is it. Let's now see if they have written the answer, right? Yeah, so this was the greatest common factor, and this is the factorization, right? Maybe we should write here greatest common factor so everybody can see. Greatest common factor, what we factored out was 3x e raised to minus x. We factor that out, and as a result, we get our derivative, right? Very good. And then if you look through, you can see that this is it, right? 3x e raised to minus x, and then followed by 2 minus x, right? So simple functions first, the complicated ones following. So now let's talk about this type of problems, right? What to do if they give you not a multiplication of two functions, but the division of two functions, okay? Such as this, right? Let me show you, let me see if we have on our notes an example. If not, I will go over one example there on the worksheet, but I believe, yeah, I have to do one here then. Yes, let me show you. Yeah, we're gonna try this, okay? Let's do this together. Let me explain to you what to do if something like this appears. It's a little bit tricky. Requires the quotient rule, okay? But besides the quotient rule, I think it requires factorization. So let me show you. All right, so later you will have a chance to practice, but let me show you this. Let's do number 3. All right, the function is this, right? It says f of x equal 9 e to the x over twice e to the x plus 1, right? It's a quotient, right? So this is begging for us to use the quotient rule, right? The quotient rule. F will be the numerator, G will be the denominator. Recall, quotient rule says the derivative of F over G is equal to derivative of F times G minus derivative of G times F all over G squared, right? This is what the quotient rule says. So let's do that. So the derivative of this function will be equal to the derivative of this guy first, 9. Sometimes students ask me, Professor, F and F here. Well, if that bothers you, you can change this for an H. Okay, maybe we should do this, right? So nobody gets confused, right? Yeah, or if you can handle it, you can just use h, right? You're talking about the first function. All right, let's use h. All right, the derivative of the first function is what? 9 is a constant, comes out. 9 comes out. And derivative of e to the x, remember e to the x, nicest function in calculus, is itself e to the x. So this is the derivative of this. But that must be multiplied by the other function, which is this, right? For the other function, I'm gonna write 2e to the x plus 1 within parentheses, right? So we keep everything organized. This is this part. Minus, derivative of g, derivative of this function. But what's the derivative of this function? Derivative of this part is 2 constant out. Derivative of e to the x itself, e to the x, right? Derivative of 1 is 0, right? 0. So this is the derivative of g times h times this other guy, 9e to the x. Now all divided by g, which is 2e to the x plus 1, is squared, right? Is squared. And hint, do not expand this, right? Keep it as it is in factor form, in exponential form, right? That's what we do with denominators. All right, great. So now what we have to do is we have to work out the numerator, right? Let's work out the numerator. So f prime of x will be equal to what? 9e to the x times 2e to the x. What is that? Well, 9 times 2, 18. E to the x times e to the x, e raised to twice x, right? When I do that, sometimes students get puzzled. I'm just doing this, guys. Right? E to the x plus x, e to the twice x, right? When you multiply power with the same way, you keep the base at the exponent. This is the multiplication. Great. Now this times 1. 9e to the x times 1 is just 9e to the x, right? Good. What about this? 2 times 9, 18. There is a negative sign in up front. Yeah, go ahead. Go ahead. Yeah, go ahead.
X squared. Why is it 2x? Like, you're making.
Oh, why? Yeah, because okay, we did this, right? Maybe we should do it step by step so nobody gets confused here. Yeah, okay, we have this task, right? 9e to the x must be multiplied by 2e to the x, right? This is this. Look, first I'm gonna switch this. The order of the factors does not change the product, right? So switch e to the x, e to the x. This is clearly 18, right? No doubt. But this part, right? You're saying why I am keeping the base e and adding the exponents. Well, because recall there is this rule, a to the n times a to the m equal a to the n plus m, right? You remember? Same base, you keep the base, you add the exponents, right? So I'm using that rule here and saying this, x plus x. So this will be 18e raised to twice x. Better now?
Yeah,
Is it? Yeah. Better? Yeah, it's just algebra. I will try to remember this rule. It's just algebra. Yeah, great. So this again, right? Look again. E to the x times e to the x is e raised to twice x. E raised to twice x. Yeah, it's a tricky problem, this. Twice x. Very good. This is this. I mean, I should do this. This part is here, right? Yeah. Yeah, very good, guys. Very good. So this is what we just did, right? This guy is this. Okay, so now on the denominator, notice we have this twice e to the x plus 1 raised to a second power, right? Raised to a second power. But now on the numerator, notice, surprise, this guy cancels with this guy. They are opposites, right? 18e raised to 2x minus 18 times e raised to 2x, 0, 0. What is left? Just this guy, right? Just this guy. So, believe it or not, guys, this f prime of x will be equal to just this, 9e to the x over 2e to the x plus 1 square, okay? So now looking at the choices, It's here, right? It's here. You can see it, right? It's there. 9e to the x divided by 2e to the x plus 1 raised to the second power. Okay. Very good, guys. So in case the quotient rule appears, this is what you're gonna do, right? Okay, now I think it's time to talk about this other function. This one we can come back later. It's just product rule for this and for this. Product rule, right? So we can do it later. This one we did. Yeah, but yeah, before we move to natural log, let's try to do this. Sometimes they will ask you to compute the equation of the tangent line of an exponential function, right? Such as y equal e raised to 8x. I'm gonna do the first one. I'm gonna ask you to do the second one, okay? Look, it's not difficult because you just have to compute the derivative to figure out the slope of the tangent line, right? And then evaluate that derivative at x equals 0, right? So the derivative of this function is going to be derivative of the outside function e raised to something, that something is the inside function 8x, right? Times derivative of 8x with respect to x, which is just 8, right? 8. So you see, we can easily compute the derivative as this, right? Times 8, or better written this way. The derivative will be 8 times e raised to 8x. This is our slope generator, right? For our tangent lines. But at x equal 0. Professor, why at x equals 0? Because of this. They are telling you, right, that this equation of the tangent line must be found when x is equal to 0. So at x equals 0, substituting this x with 0, we get that our slope of our tangent line will be this: 8 times e raised to 8 times 0, right? 0. A slope over a tangent line will be 8 times a raised to what? 8 times 0 is 0, right? 0. And anyone could tell me what is e to the 0? E to the 0. Remember?
1.
1. Excellent. 1, right? Very good. Any positive number raised to 0 is 1. In particular, is E Euler number, which is 2.71 raised to 0, 1. So bottom line, the slope of the tangent line will be 8 times 1, 8, right? 8. 8 is the slope. Now, with that slope, with the slope 8, and with a point 0 is the x coordinate, right? Professor, they didn't give me the y coordinate. Not a problem, guys, because the y coordinate can be found using this function, right? With input 0, the output should be e raised to 8 times 0, right? 8 times 0. So you just do an evaluation and you get your output value there. So not a problem. This is 0. And remember, this is e raised to 8 times 0 is 0. E raised to 0 is just 1. So bottom line, you're looking for a line whose slope is 8 and has a point 0, 0.1, right? 0, 0.1. And then using y minus
sorry,
y1.
Professor.
Yeah, go ahead. Go ahead.
So why is it e raised to 8 times 0 and not e raised to 8 times x?
Oh, no, in general, the function is this in general, right? F of x, the function tells you for the input value x, the output value should be e raised to 8 times x, right? But I am trying to figure out what is f evaluated as 0, right? Because they're saying that the input value is 0, right? So in order to find the output value that corresponds to 0, I must substitute wherever I see x 0 instead, right?
Oh, okay, I see.
Yeah. It's tricky. I must acknowledge it's tricky because working with this stuff on the top. Yeah, but is this now you follow, right? E to the 0, 1. So look, all this madness is just 0, 1 in reality, right? So now we go and say this is my x1, which is my y1. Y minus y1 equal a slope of the tangent line x minus x1. You can apply any method, you know, to retrieve your equation, the equation of your line. Y1 is 1. The slope is 8m. Here x1 is 0, right? 0, which will vanish, right? This disappears, 0 disappears. So we end up with y minus 1 equal 8x. Transposing this 1 to the other side, equivalently adding 1 to both sides, I end up with y equal 8x plus 1, right? And that should be the equation of the tangent line, right? This guy, right? Very good. So you understand, guys, when they ask you for the equation of the tangent line, take the derivative. That will give you the slope at any value of x. Use this value of x to find your slope, right? Take advantage of this property that says that any positive number raised to 0 is 1, right? Use it. Or you can have this in your calculator too. Sometimes sometimes students say, Professor, can I get this in the calculator? Yes. If you go to functions, e raised to 0, you can see there's 1, right? It's 1, so in case you forgot, it's there. All right, great. So now, can you try this so we can move on to the natural logarithmic function? Try this, guys. Let's find the equation of the line, right? Find equation of tangent line. At x equals 0, right? At x equals 0. Yeah, very good, very good. So, yeah. Great. Yeah, f of x equal 3 times e raised to minus 8x. That's the function. So you're going to find the derivative, right? Somehow. Advice, take this constant out and focus on getting the derivative of this, right? And then substituting the value of x, you can get the slope. With the slope, you can get the equation of the line. Yeah, right. Right. Aha, I see. Students figure this out. Adriana, let me check number 9. Very, very good, Adriana. Yeah, you made my day. Sarah, Grace, Oscar, very good, guys. Very good, very good. Okay, let's do it together. Okay, let's do it together so we can move to the derivative of the natural logarithmic function. If we take the derivative, taking 3 out, we focus on getting the derivative of this guy, right? E raised to minus 8x with respect to x. But what is that derivative? Well, this derivative, if you consider this function to be your outside function, e raised to something, and this guy minus 8x, your inside function, right? The derivative is the function, the outside function itself, e raised to something here. That something is the inside function minus 8x times derivative of minus 8x is just negative 8, right? Negative 8. So this, believe it or not, guys, is the derivative of our function at any value of x. This is it. This is our slope generator. Oscar, yeah, very good, Adriana. Very good, guys. So now this is the derivative in general, right? But I really want the derivative at x equal 0. Why at x equals 0, Professor? Because of this. This is telling me, right? This is my input value. All right, so that derivative will give me the slope of the tangent line, right? Slope of the tangent line. So that's going to be minus 24 e raised to minus 8. This 0 must be substituted instead of x, right? And evaluating exponential function at x equals 0 is a good thing to do, because notice if this is negative 8 times 0 is 0, e to the 0 is just 1, right? 1. And 1 times negative 24 is negative 24. So the slope is going to be negative 24. Now the point is going to be this 0, the first coordinate. The second coordinate I do not have, but I have my function, right? I have my function. I'm gonna highlight here. I have my function. This I'm gonna use that function, right? I am going to evaluate that function at x equals 0, right? And remember, guys, evaluating exponential functions at x equals 0 is not difficult because of this. Look, minus 8 times 0 is 0. E to the 0 is 1. And 3 times 1, of course, is just 3. Right? So the point is really 0, 3. Right? And the slope, minus 24. With this slope at this point, using the point slope form of the equation of the line, where x1 is this and y1 is this, well, you get that y minus y13 equal slope minus 24 times x minus x10, right? This disappears. So simplifying this, adding 3 to both sides, once you eliminate this, right? Minus 24x plus 3 here, and here these two cancel. Very good. So y equal minus 24x plus 3 should be the equation of the tangent line, right? At x equals 0. So if you look through, it's here, right? Excellent, guys. Excellent. Very good, very good. Yeah, try to recall this for your homework, guys. It will help you a lot. All right. This one you can do it at home, is similar, but now we must talk about the derivative of the natural logarithmic function. Remember, guys, from pre-calculus or from your previous knowledge, right? The natural logarithmic function is the inverse function of the natural exponential function, right? The natural exponential function was like this, right? Increasing this way. And this new function is just the mirror image of that function, but has the shape, right? And by the way, if you have trouble remembering those shapes, guys, we have a tool, right? We have this basic graphing calculator, right? This was e to the x, remember, right? But then now I want y equal ln of x, natural log of x. Look, it's this, right? That I just did here. Now notice, right, this, it seems like this is touching the y-axis, but in reality it never touches the y-axis, right? It never touches the x-axis, neither this red function. All right, so this is it, right? Okay, now the natural logarithmic function meets the x-axis at 1, 0, 1, 0. Let's be careful there. 1, 0, right? Goes like this. And now, since we are doing calculus, we have to figure out the derivative of this function, right? The derivative. So for that, recall g of x equal natural log of x is the inverse function of the function f of x equal e to the x, right? That we just studied before, right? And by the way, we have a way to compute the derivative of this function, right? So we can use properties of inverse functions and figure out the derivative of the inverse function of this guy, which is going to be the derivative of this natural log of x. All right. So remember, the derivative of an inverse function is 1 over the derivative of the original function evaluated at this inverse function, right? So the derivative of this guy will be 1 over the original function, which is e to the x, right? E to the x, e to something. But inside here, you must keep this inverse function, natural log of x, okay? This. But now, guys, simplifying this, and for what I'm gonna write on the side, recall, what is this guy? E raised to natural log of x, knowing that the base of this natural log is e itself. What is e raised to the natural log of e of x? Natural log base e of x. That's how you read it, right? I will give you a hint. When the base here is the same as the base here, these two guys cancel. These two guys cancel, and the result of this, believe it or not, guys, is just x. Why is that, Professor? Well, because notice, right, that log is the exponent you raise the base to get the argument, right? So they are saying raise e to the natural log of e, the natural log of x on base e, right? So this guy has to return x because it's precisely the exponent you raise e to get x, right? Yeah, it's a property. E cancels x. So bottom line, this guy is just x, right? This is e. So this one, 1 over x. Another surprising result, guys. The derivative of natural log of x is simply 1 over x, 1 over x, okay? Try to memorize that because we're gonna use this result a lot. The derivative of natural log of x equal 1 over x. Now, sometimes students at this point, they ask me, Professor, where are these formulas? Even though they are easy, I would like to know where they all together. I have posted in our website another sheet with formulas, and they include the derivative of e to the x and the derivative 1 over x. Is this? I can give you the link now. It's together with this antiderivative. We're going to do it later, but if you want to focus on the left column, they are there. Look, derivative of natural log of x, 1 over x. Here you see this absolute value. Ignore them for a moment because when you take natural log, clearly this guy must be positive, right? Taking natural log negative numbers wouldn't make sense. So don't worry about this for now. And the derivative of e to x is there, these two, right? In case you need these results. I can give you this sheet now. The link is here in case you need it. You should print this out too. In the end, it will help you for the final, especially. All right. So derivative of natural log of x, 1 over x. But remember, just like before, very often they will ask you to compute the derivative of natural log, of some function of x, right? Not necessarily x, right? In general, they might ask you to compute the derivative of natural log of x squared, the derivative of natural log of x cubed minus 1, natural log of sine. This might be a function. So in general, using the chain rule, if you encounter this form, you should proceed this way. 1 over the function, right? The function which is h of x, right? 1 over this guy times the derivative of this guy. So basically, this acts like the inside function, right? The derivative of that function is 1 over this, right? 1 over this. Let's in here. 1 over the argument of the log, but then times the derivative of this inside function. All right. Okay. Example 1. Find the derivative of 3 times natural log of x plus 7. Solution. Quickly, we do this, right? The derivative of this function is going to be the derivative with respect to x of 3 times natural log of x plus the derivative with respect to x of this constant function 7, right? I simply distribute the derivative over the sum, which is something that we can always do, right? Next, look, number 3 is a constant. Take it outside of the derivative, right? Focus on getting this derivative, okay? Plus this derivative. But who can tell me what's the derivative of 7? Anybody? Derivative of 7 equal?
0.
Great, 0, right? The derivative of a constant function, guys, always 0. In any context, 0 disappears. We stay with this, but this will be 3 times. What is the derivative of natural log of x? We just said that, right? It's just 1 over x, right? And then finally, you multiply 3 times 1 is 3, x on the bottom, 3 over x is the answer, the final answer, right? Excellent. So this was the first example, right? Direct application of this formula, derivative of natural log of x, 1 over x. But now let's talk about this other form, right? When you have to do this. Well, whenever the argument is not x, but some function of x, right? We're going to use the chain rule there. For example, look at this. They want you to compute the derivative. The function is given here, f of x equal 5 natural log of this function 8 times x, right? So the derivative of this function should be phi out, right? Phi is a constant. And we should just focus on taking the derivative with respect to x of this guy, natural log of 8x, right? Natural log of 8x. All right, so this is gonna be f prime of x, the derivative, phi, constant. What's the derivative of this guy? Notice that the rule says, right, if you have a function for the argument of your natural log, then you have to use the chain rule, right? You have to consider natural log to be your outside function and 8x to be your inside function. So you still go ahead and say, okay, the derivative of the outside function natural log is 1 over the argument, right? 1 over the argument. So 1 over 8x. But this must be multiplied by the derivative of this guy, derivative of 8x, right? Respect to x, and you will see something surprising there. Then we have derivative of f equal 5 times 1 over 8 times x times the derivative of 8x respect to x is just 8, right? Just 8. So the surprise is this. Look, the 8 here cancels with this 8, right? So 1 over x stays there, right? So it turns out the 8 really doesn't matter, right? It could be any number that they're going to cancel. So the derivative here then will be equal to 5 times 1 is 5 over x, right? Over x. So final answer. Very good, guys. So now I think it's time for you to practice before we go over these forms, and then we'll talk about some properties of logs that you should apply in some cases. But I want you to practice first. So can you try to get this? Do this. Y equal natural log of 6x. Can you take the derivative of this? Recall derivative with respect to x of ln of x is just 1 over x, right? Recall that, use that for this. So y prime. Try this, guys. And the hint, look at this as your outside function. Look at this as your inside function. I see students already figure this out. Let's see, number 1. Sarah, very good. Adriana, very good. Oscar, very good. Yeah, it's not that difficult, right? This is a little bit tricky because look, the derivative of the outside function natural log is 1 over the argument of this, right? So this 1 over, we should write it here so nobody gets confused. More space here. Yeah, the derivative is equal to what? Derivative of the outside function 1 over the argument of the log 6x the inside function, times the derivative of 6x with respect to x. But here comes a surprise, right? This is 1 over 6x. Derivative of 6x is 6, right? 6. The number 6 will cancel the number 6 on the bottom. So bottom line, believe it or not, guys, this derivative is just equal to still 1 over x, 1 over x, okay? Still. So we're talking about this guy. Now I'm gonna write this is a property in case you wanna catch this nice property. The derivative with respect to x of natural log of kx, that's the way, right? Derivative with respect to x of natural log of k times x is equal to 1 over x still, okay? This k does not matter, as you can see, right? 6x, the 6 didn't matter because it gets canceled. This is where k is a constant not equal to 0. Any constant, right? 3, 4, this is the same. All right, great. So continue with this, guys. Try to this one, number 2, y equal natural log of x minus 2. Let's try this. Figure out its derivative, right? And the hint, again, is that this should be considered to be your outside function. And this you should consider to be your inside function. I see some students posting answers here. Number 2. Very good, excellent, Grace, Oscar, Adriana, Sarah, very good, guys, very good, right? The derivative, more students are posting. Ruby, I think, Ruby, you have to check something there, it's very close, but I think you missed something. The plus should be mine, but we'll see. The derivative of natural, now it's correct, Ruby. Very good. Yeah, so the derivative y prime should be equal to what? 1 over the argument of the natural log, the inside of the natural log, x minus 2 here, times the derivative of this guy, right? But the derivative of this guy is just derivative of x is 1, derivative of this 0 is 1, so it's not going to change anything. So this ends up being just 1 over x minus 2, right? 1 over x minus 2, which is this guy. Very good. Try this one and we will move on. Y equal natural log of, let me use parentheses, 8x squared. Can you try this? Again, the hint, look at this natural log as your outside function. And look at this 8x squared as your inside function, okay? Yeah, go ahead. Y prime. Use a chain rule, right? Simplify if needed. I see some students are posting answers. Let's check. Number 3. Very good. Adriana, you got it. Yeah, you got it. Yeah, very good. Oscar also, very good, guys. Very good. Mhm. Yeah, it's not that difficult as long as you know the formula to differentiate the function y equal natural log of x, which is 1 over x, right? And that together with a chain rule, right? So look, the derivative of the outside function is this 1 over whatever is inside the natural log, right? In this case is this 8x squared. But that's again there because the chain rule says that then you have to multiply this by the derivative of this guy. Derivative of 8x squared, that's the derivative of the inside function, right? So y prime will be equal to what? 1 over 8x squared time derivative of this guy is 2 coming down multiplying 8, 16 x, right? X, that's all. What is left is just algebraic simplification. 8 into 16 is 2. X squared, x here, 1x cancel, 1x stays on the bottom, right? 1x stays on the bottom. So final answer should be this. Excellent, excellent, excellent. For number 3. Excellent, excellent. Now I see here a quotient rule, right? Quotient rule. So let's practice here the quotient rule. So try to do this, guys, and that will give you a hint, okay? Do this. Y equal natural log of x over x to the 5th. Hint, use quotient rule. Hint, use derivative of f over g equal f prime g minus g prime f all over g squared, right? G squared is called quotient, right? Use this with this guy playing the role of f, with this guy playing the role of g. Yeah, use that. I see. For number 4, let's check. Let's check some students posted answers. Very good, Adriana. Very good, Oscar. You guys got it. Very good, very good. Excellent, excellent, right? It's an application of what we call the quotient rule, right? The quotient rule. So let's do it together, right? The derivative of this function should be derivative of f. This is how the quotient rule starts, right? Derivative of the numerator. We know that the derivative of natural log of x is 1 over x, right? 1 over x. This is this. Times the other function as it is, x to the 5th. Minus the derivative of the g function now. Derivative of x to the 5th power is 5x raised to the 4th power times the other function as it is, natural log of x, right? We have it here. All divided by g squared. This guy is squared. X to the 5th is squared, right? Square. All right, great. So now let's simplify. Y prime will be equal to what? Look, x to the 5th times 1 is x to the 5th divided by x to the 4, right? X to the 4 minus 5 x to the 4 natural log of x all over x to the 5th raised to the 2nd power. Remember, you multiply these two, right? This and this. That justifies this x to the 10, right? X to the 10. Multiply those two. Very good. Now, remember, mathematicians, when it's possible to factor something out, they do that, right? They do that. So look, this guy x to the 4 appears here as well, right? So x to the 4, x to the 4. So let's factor that out. Let's factor that out. So x to the 4 out, right? Is this and this out, and what stays inside here? X to the 4 into x to the 4 is just 1 minus here x to the 4 into x to the 4, 1, 5 times natural log of x stays there, right? Stays. And all this divided by x to the 10, x to the 10. Now I want you to pay attention to these two guys. Look at this guy and this guy. It's possible to simplify them, right? To simplify them, right? This x to the 4 with this x to the 10, right? So simplifying, we're gonna get, yeah, we're gonna close this and open this up again for you. Yeah, what happened with our stuff? Yeah, let's just redo it quickly. We said that y prime, derivative of this 1 over x times g, x to the 5th, minus g prime, the derivative of this 5x to the 4th, times the other guy, natural log of x. We said that, right? And then everything divided by this guy squared. Okay, but then simplifying, x to the 5th divided by x to the 4th, minus 5x to the 4th times natural log of x over x raised to 5 times 2, 10, right? 10. All right, then we said that we factor out x to the 4, right? This guy, x to the 4 must be factored out. Let's use circles here. X to the 4 into x to the 4 is 1 minus x to the 4 into this expression, x to the 4 cancels. What is left is 5 times natural log of x all over x to the 10. Finally, the last part is this. X to the 4 and x to the 10, they can be simplified, right? 4 x's are canceled, but 6 x's are left, right? X to the 6 here, right? You take the difference, 10 minus 4, 6, right? You place it in the bottom because this is the dominant. So this is it. This should be the answer, right? So look through, and it should be there. It should be there. It's here, right? Mm-hmm. I think it's, yeah, great, excellent. Mm-hmm. Yeah, just follow this through with the algebra, and you should be fine, guys. You should be fine. So very good. Let's move on. Okay, so this in case they ask you for the quotient rule. Now, this is the product rule. Can you try this? And then we will move on to this guy. And I think we have to now then explain how to use the properties. Try this. Y equal x to the 6 natural log of x minus 1/3 x to the 3rd. Take the derivative, distribute your derivative. For this part, use the product rule. I'm gonna write the product rule, recall. Product rule says f times g derivative is equal to derivative of f times g plus derivative of g times f, right? Use this for this part, and this is easy to differentiate, right? This 3 comes down. Yeah, go ahead, guys, and try to get this done. So we can move on to using properties of logs to figure out derivatives. Mm-hmm. Mm-hmm. I see. For number 3. Let me check this out. CG. Yeah, you got it. Very good, very good. CG, you got it. Adrian, I think you have to adjust something. Well, CG, this is number 5. Oh, you guys are correct. I was looking at another question. Adriana and CG, correct. Oscar also, very good, guys. Excellent, excellent. Yeah, you're right, Yeah, using the derivatives, distributing the derivatives over the difference, you have to take the derivative of this minus the derivative of this, right? But what is the derivative of this part? Using the product rule, start with the derivative of x to the 6. That derivative is just 6 coming down, x to the 5th power, times the function g natural log of x. Now, plus, I'm still taking the derivative of this guy. Derivative of g now, derivative of natural log of x, 1 over x, right? Times the other guy, the other function as it is, x to the 6, right? This is it. This is this function. This derivative is easy to compute because it's 1/3 constant, 3 comes down, and this x stays with exponent 2, 1 less, right? Yeah, that's the derivative. Now, you just have to simplify this. Y prime will be equal to 6x to the 5th power multiplied by natural log of x plus x to the 6 on the top divided by x to the 5th. 3 and 3, they cancel. They cancel here. A lot of algebra there too. And then x squared stays, right? Minus x squared. So this should be something that you have to look for among the choices, right? And turns out it's just this guy. You may say, Professor, but it's all scrambled. I will show you. Notice this guy. Again, kind of consistent with the rule that I gave you, right? That somehow mathematicians tend to write the complicated stuff at the end. Yeah, again, this went off, but let me just write it quickly. Derivative of the first 6x to the 5th, this, plus derivative of the other guy, 1 over x times x to the 6th. This was this, right? Minus derivative of this guy, 1/3 constant, and 3 times x squared. Then we were saying that this is 6x to the 5th power natural log of x plus x to the 6th divided by x to the 5th power minus this to cancel x to the 2nd power. What I was trying to say is that this guy appears at the end, right? Kind of mathematicians, the complicated stuff, they push it to the end. The simple stuff, they bring it up. So then the x to the 5th is here. So don't get lost, guys, if you're looking at this. And the x squared is here, right? Everything's there. So we don't know this, right? Yeah, very good. Very good, guys. Number 6, let's try to do it together. Let's erase this. What about this nested function, the natural log of the natural log of 2x? How can we take the derivative of this? I'm gonna do this to you to show you that this is just an application of the chain rule, okay? If we write this way, notice that the outside most function is this natural log, right? This is just the inside function. So I start by taking the derivative of the outsidemost function, which is this natural log, right? The derivative of that is 1 over whatever is inside the log, right? It's called the argument of the log. Whatever is inside the log is this. Let me write it in red, so, right? But then you're supposed to multiply this by the derivative of this guy, right? By the derivative of this guy, yeah. So this was the outside function. Then you are supposed to multiply this by the derivative of this guy, which is itself another composite function, right? So you're gonna apply the chain rule again. And finally, you're gonna get 1 over natural log of twice x times derivative of this guy. Remember, there is a property that says that this number doesn't really matter, right? I gave you that property. But if you forgot the property, just take the derivative, you will see that the number 2 will disappear. Twice x here, 1 over twice x, the derivative of the outside function. And the derivative of the inside function is just 2, right? 2. And as you can see, this number 2 cancels this number 2, disappears the number 2. So final answer will be 1 over x multiplying this part, right? 1 over x multiplying this part. So which is, believe it or not, guys, it's just this. I'm gonna write this 1 over x at front, multiplying this 1 over natural log of twice x. I will drop the parentheses, I don't need them anymore. So final answer is, right, 1 times 1 over x multiplying natural log of twice x. Okay, you follow, guys? So this should be this, right? Number 6. Very good. All right, can you try this? And then we will move on to, oh, but this one requires the property. Yeah, this two require the property. All right, let me explain number 7, and probably I will let you do number 8, okay? Sometimes it is better to use properties associated to logarithms, in particular to natural logarithms, right? In order to simplify the expression so that the computation of the final derivative becomes easier. What are you talking about, Professor? Well, notice this, right? This function, natural log of 4 theta multiplied by e raised to minus theta. If you go ahead and directly apply the chain rule, notice the inside function is complicated, right? The inside function is complicated. You have to apply the product rule. But sometimes, again, it's better to do this first. First, simplify using properties of logarithms. For example, there's a property for logarithms that says that the logarithm or the log of a product is equal to the sum of the log, right? You saw this property when you took pre-calculus, right? Log of a product is equal to the sum of the log. All right, so if we use this property, then we can say that this y that we have here is just really this. If you call this guy A and this guy B, you're gonna have that this is natural log of 4 theta plus natural log of e raised to minus theta, right? Follow, guys? This becomes this using this property. Further, look, again, I have here a product 4 times theta, A times B. So I can say that this can be expanded as this natural log of 4 plus natural log of theta. There is a property for logs that says the log of A raised to K is equal to K times log of A, right? The exponent can be taken outside as a constant multiplying the log, right? Remember this property? So I'm going to apply this property here to this exponent negative theta. So this will be minus theta multiplied by natural log of E. Professor, why you're doing all this madness? Well, notice, guys, natural log of 4 is just a real number. The derivative of this will be 0, right? So that this is how you simplify. Now, the derivative of natural log of theta I know is 1 over theta, so very simple. So now, what is this? Natural log of E, natural log of E. Notice that the base for natural log is E, right? And remember what happens when the base repeats itself here. They cancel, right? They cancel, it's a property. Natural log base E of E is just 1, right? This is 1. Natural log of E is just 1. So look how I simplify everything, right? Everything gets simplified. So this is why. This is this. Simplify. Now take your derivative, right? Now take the derivative. Now take the derivative after simplifying. Now take derivative. So you will see that it's simple. Derivative of this guy is derivative of natural log 4 is a constant, right? It's a real number, so 0 plus derivative of natural log of theta, 1 over theta, right? And derivative of this guy, minus 1, right? Minus 1. So finally, I get that the derivative is just equal to 1 over theta minus 1. That's it, right? 1 over theta minus 1, and it appears here, right? You follow, guys? Otherwise, very difficult to get, because if you don't do this simplification, you might have to deal with the product rule inside there. It's more difficult, perhaps, right? So use properties of logs before taking the derivative. Okay. Can you try now this? This one is something similar, but instead of using this property, log of A times B equal log A plus log B, we're gonna use this other property. I'm gonna write this as a hint here. Hint. Log of A over B equal to log of A minus log of B, right? Use this. Log of A minus log of B. So first simplify. I'm gonna write it here clearly. First simplify. So using this, right? Using this fact. So basically y equal natural log of e to the theta over 10 plus e to the theta should be this. This is gonna play the role of A, and this is gonna play the role of B, okay? So try to do that, guys. So simplify first, and then take the derivative once everything is simplified, right? Yeah, very good. Now take the derivative. Oh, yeah, this problem is very tricky. So try, give it a try, and then we will do it together, okay? So together. And then we'll go over the last part. This is when the base is not E. What to do? Yeah, we'll continue this as a hint. Yeah, e to the theta. This is minus natural log of 10 plus e to the theta. Yeah. This is y, right? And now take the derivative. You're going to simplify this too. I'm going to give you a hint. Here there is an e. Base e, they cancel, right? So try to follow that. That will help you. E with e cancel. This is just theta. And minus that, and then take the derivative. Yeah, very good. So y Now take the derivative of y. Mhm. Okay, let's try to do it together, okay? It's very tricky. So you simplify first this way, the natural log of e to the theta, having as a base e, is just theta, because remember the natural log is always the exponent, right? The exponent, or equivalent to, if you pull out the exponent, natural log of e is just 1, right? 1 times theta is theta. So this is theta. This part stays like that. Now it's time to take the derivative. So if you do, y prime will be equal to what? Derivative of this theta. Derivative of this theta is just 1, right? Minus derivative of this. But the derivative of this, if you consider this to be your outside function and this to be your inside function, will be equal to what? Let's see. It will be equal to 1 over this guy inside 10 plus e to raised to theta times the derivative of this inside function, right? The derivative of the inside function is derivative of 10, 0, derivative of e to the theta, e to the theta, e to the theta. So this is pretty much the answer, but probably we have to simplify here. Y prime equal 1 minus theta times 1 e to the theta over 10 plus e to the theta. Now, 1 is the same as 1 over 1. Multiply by the LCD here, 10 plus e to the theta times 10 plus e to the theta. This is just algebra, guys. So 10 plus e to the theta minus e to the theta. Common denominator, the LCD, 10 plus e to the theta. E to the theta cancels with e to the theta. And what is left is just 10 on the top, right? So y prime should be 10 on the top, all divided by 10 plus e to the theta. Okay, this should be the final answer, right? So this is somewhere here. I think it's B, right? This. So when you see quotients inside a log or products inside a log, use these properties from logs that you learn from pre-calculus, right? To facilitate the computation of your derivatives, okay? All right. So now let's talk about the last part, which deals with the answer to this question. What if the base is not e? We know how to take the derivative of natural log of x, right? But what if the base is not e? What if they ask me to take the derivative of log of x base 10, for example, right? Or log base 7 of x. What if the base is not e, right? So we gotta figure out how to still get our derivatives, right? So, and we're gonna do that for the natural exponential function, for the natural logarithmic function, when the base is not e, right? In general, for any base. Mathematicians then started by figuring out the derivative of this guy first, derivative of b to the x with respect to x, not e to the x, right? B to the x, where b is some real number, positive, right? Well, then they figure out that this derivative is going to be itself, right? Just like when you take the derivative of e to the x, but to compensate for the fact that this is not e, it's just some base b, you're going to multiply by natural log of b. You follow, guys? This is the formula. Derivative of b to the x with respect to x is equal to b to the x times natural log of b, okay? Natural log of b. Now, similarly, mathematicians figure out a formula to take the derivative of log whose base is not e, not natural log necessarily, right? Log with any base b. And it starts by this 1 over x, just like when we had natural log, right? 1 over x. But to compensate for the fact that this base is not e, it's just any base, any real number, any positive real number, right? Then you have to attach here ln b. Follow, guys? So this attached here, this attached on the denominator, okay? So these are the two formulas. Try to write them down in case you don't remember them. We are going to use them now. Okay, so first example. Example 1 says, find the derivative of this guy, 6 to the x, not e to the x, right? 6 to the x. All right, so let's do it, right? What should be the derivative of the function 6 to the x with respect to x? Let's follow our formula here. The formula says this is equal to 6 to the x, b to the x, right? But then to compensate for the fact that this 6 is not e, you have to multiply by natural log of the base, natural log of 6, right? So it's a very straightforward formula. So you write 6 to the x first itself times natural log of the base, whatever it is 6, 6. So that's it. This is the answer. Okay. Example 2. What if they ask you to figure out the derivative of this composite function y equal log base 7 of 8x minus 3? Okay, this is a composite function. So first step, let's clearly identify what is our outside function, right? Happens to be this log base 7 of something, right? This something supposed to be our inside function, right? 8x minus 3. So let's apply the chain rule together with the formula that we have here, right? Okay, so therefore, the derivative of y should be the derivative of the outside function. But what's the derivative of the outside function? Log base 7 is this 1 over the argument, right? Whatever is inside there, 8x minus 3. But since we're not dealing with natural log, we're dealing with log base 7. Here we have to attach this natural log of 7, right? Times the derivative of 8x minus 3 with respect to x. And anyone in the chat could tell me what's this derivative? Derivative of 8x minus 3?
8.
Yes, 8, right? Very good, guys. Very good. You are tuned. Just 8 because the derivative of 3 is 0. Excellent, right? So putting all this together, basically this tells us 1 over 8x minus 3 times natural log of 7 times the number 8, right? The number 8. And therefore, the answer for this question is just this. 8 times 1, 8 over 8x minus 3. Notice I'm writing this within parentheses, right? To keep it separated from this natural log of 7. That's it. This is the answer, right? This is the final answer. Okay, so the formulas are simple, but you just have to be aware if you are dealing with composite functions, right? And apply these formulas accordingly. So let's try to go over this worksheet then. Can you try the first one, number 1? This guy. I will give you time here. This y equal 10 to the x. Find the derivative, right? Derivative of this. And as a formula, I will right here recall the derivative of b to the x with respect to x is equal to b to the x itself times natural log of b, right? To compensate for the fact that this is not e, right? It's just some real number b. So use that formula, try to figure this out. I see the students posting answer. Yeah, this formula is not that complicated. Ruby, very good, very good. I see also Grace, very good, very good. Sarah, Adriana, right? Adriana, Oscar, Adriana, very good, guys, very good. Yeah, remember we said that derivative, you start with this guy.
I'm
This
sorry.
guy,
So whether,
yeah, go ahead, Sarah.
so whether you have 10x square, is you're gonna just take 2 times the 10, and then you do natural log 10. Is that how it's gonna be? Wasn't it 10 x?
10x to what? X squared, something like this?
Yes.
Then you have to do the composite function. We will see some examples on the bottom, okay? But if not, I will make up an example for this case, okay? But it will come down.
An example of that, and if it's like a square root, like 1 over x, something like that.
Yeah, let's go through the worksheet first from basic to more challenging, and then if we don't encounter this when we finish with the worksheet, I will make up something for you, okay? Yeah, but this can be done too. Yeah, very good. Yeah, very good, very good. Yeah, it can be done. All right, so everybody agrees with this, right? Yeah, this is the answer, applying our formula. So clearly this is this. Yeah, let's go from basic to more complicated. Now this guy, number 2. Anybody can tell us the derivative of this? Similar to the previous, right? Direct application of the formula. Very good, Ruby. Very good, Oscar. Yeah, Sarah, Grace. Very good, right? Excellent, right? The base instead of 10 now is just 4. So again, the derivative is just itself. You start with itself first, but since this is not e, it's 4. To compensate for that, you multiply by natural log of the base, right? This. So there's this guy. Excellent. Done with that. Now let's go to this over this form. Let me show you this, and then or you can try this probably because we did an example, right? So try it. It's not that difficult. Y equal log of 8x, and the hint is treat this as your outside function and this as your inside function. Notice that it's no longer natural log, it's log base 10. And you may say, Professor, how do you know it's log base 10? Well, because there's an agreement, right? If the base is not shown in the log written in this way, log, the base is 10, right? So consider here 10 as the base. And apply this formula. Recall the derivative of log base b of x, right? Not natural log necessarily, right? But let's say the base is b, is equal to 1 over x multiplied by natural log of the base, right? This is the formula you have to apply here together with the chain rule, right? Together with the chain. So go ahead, guys. I see. Number 3. Ruby, yeah, you made my day. Adriana also. Very good, guys. Very good, very good. I see you have understood this formula. Yeah, it's not that complicated. It's less complicated than before, but it's just that you gotta follow the formula strictly, right? This formula. And these formulas, guys, the last two formulas, write them down because I don't have them in worksheets. It's just that you need to write them down probably from here, okay? Or from your notes. All right, very good. Very good, right? This is log base 10 of 8 times x. Outside function, log base 10 of something, inside function 8x. So the derivative of the outside function can be gotten following this formula, right? So it's going to be what? 1 over the argument of the log, whatever is inside 8x in this case, right? Multiplied by natural log of the base. The base is this invisible 10 there, right? Base 10, natural log of 10. But it's not over because you gotta multiply this by the derivative of your inside function, right? According to the chain rule. But this shouldn't be a problem because this is gonna be 1 over 8x multiplied by natural log of 10 times the derivative of 8x is just 8, right? 8. So putting everything together, after canceling this 8 with this 8, believe it or not, guys, remember these guys cancel, you get 1 over x times natural log of 10. That's it, okay? Yeah, very good, guys. So this guy, right? Yeah. Can you try this one, number 4? Practice, guys. Questions like this probably will come out in your exam number 2. Some of them will be short, but you gotta know what to do, right? And in case you didn't memorize the formula for the derivative of log base b, not necessarily base e, the formula is this. It's not that difficult. It's very similar to the one for natural log, 1 over x, but to compensate for the fact that you're not dealing with natural log, you're dealing with base b instead of base e, you attach here ln b. This is the formula. I see. 4 students posted. Very good. Very good, guys. Yeah, you made my day. Yeah, Ruby, Oscar, Sarah, Adriana. Very good, guys. You're sharp. Great. What should be the derivative of this guy? Knowing that this is the outside function. Professor, there is no base. Well, when you don't see a base and you see log, means that the base is 10, right? 10. Yeah, great. So this is something that we know. This is the inside function. So the derivative of this function, this composite function, will start with the derivative of the outside function, which should be this 1 over x, but this x is really what is inside the log, right? It's called the argument of the log twice x, multiplied by the natural log of the base, 10, right? Times the derivative of the inside function, which is the derivative of 2x. That is just 2, right? 2, not hard to figure out. So 1 over 2x natural log of 10 multiplied by this guy, which is just 2. Notice that that 2 disappears. Look, cancels with this 2. So believe it or not, guys, this is just equal to 1 over x natural log of 10, right? Yeah, so it's this, right? It's this. Yeah, you will say, Professor, same as before. Yeah, because remember, guys, what I told you, right? When you deal with logs, these guys do not change the answer of the derivative somehow, right? These guys are irrelevant, right? Yeah, it's a property I gave you, right? Yeah. Very good. So excellent. Yes, follow your rules and what you will get, this will be for sure the answer, right? That's that. Very good. Now this is another form. Can you try this now? 5. y equal log, no base, professor. Well, that means base 10, 2x minus 7. Try this. Hint, this should be your outside function. And this should be your inside function, 2x minus 7. It's not difficult to give it a shot. Number 5. If you need the formula, you can write it again. Recall. Derivative with respect to x of, I see students already posting answers. This is 1 over x multiplied by natural log of b. This formula, write it down somewhere. You will need it for your exams. Yeah. Very good, Oscar, Ruby, Grace. Great, guys. Sarah, very good, excellent. You figure this out, right? Yeah, remember, it all starts by taking the derivative of the outside function, which is log base 10 of something. That derivative is this, 1 over the argument, the inside of the log, 2x minus 7 times natural log of the invisible base 10, right? Invisible 10 there. But it's not over, because then you have to multiply this by the derivative of 2x minus 7. Respect to x is the derivative of the inside function, right? According to a chain rule. So this simplifies to the following: 1 over 2x minus 7 multiplied by natural log of 10 times the derivative of this guy. Once you distribute this derivative over, is just 2, right? 2 derivative is 0 times 2. Notice I cannot cancel this 2 with this 2 anymore, right? This is a binomial. So 2 over 2x minus 7 times natural log of 10, right? Yeah, and this, very good, guys, for number 5 is this guy, right? Excellent. This. Notice that they put the natural log up front, this at the end. Very common, I explained, right? It's just the way mathematicians write stuff, right? The simple stuff first, the complicated stuff at the end. All right, great. So now try this. This is tricky. And this is probably something that students were asking me, right? Yeah, something like this. What if the function appears on the top? Yeah, and maybe we should do this. Can you try it? Maybe if not, let me know. Yeah, try this too. Hint. Recall, derivative with respect to x of b raised to x is b raised to x times natural log of b. This is what you have to apply here. Professor, could you tell us what is the outside function? What is the inside function? Sure. This should be your outside function, 10 raised to something. And your inside function should be this, natural log of 5x, which is at the same time a composite function, right? So be careful there. Very tricky questions. Yeah. Okay, guys, let's do it together, okay? Let's start with the derivative of the outside function, 10 raised to something. That derivative can be gotten by following this formula, right? B10. So that derivative is itself 10 raised to this, right? Multiply by natural log of the base, which is 10, right? This is this. But then we have to multiply this by the derivative of our inside function, right? This is to t. But what is this? Let's write this nicely. Or let's just develop this, right? What is this? This guy is 1 over 5t, right? Derivative of side function times derivative of the inside function 5. And the 5s, remember, they cancel, right? So it's just 1 over t. Remember, I gave a property, right? This constant does not matter for the derivative of natural log, right? It's just 1 over t. So 1 over t multiplying this, multiplying this. So conclusion here, they should be equal to natural log of 10, I'm going to write it up front, divided by t is in the bottom, multiply by this whole thing, right? 10 raised to natural log of 5t, right? You see it here on the top. For this, the answer for number 6 should be the last one. Maybe I should use highlighters. Look, this part is here. And this part, they drop the parentheses, right? Something the mathematicians often do. When they don't need parentheses, they drop them. But this part is that, right? Yeah, very good. Great. Number 7 now. Can you try number 7? I think it's easier. Yeah, we're coming down to the end of this. Y equal 3 times natural log of, I'm gonna place this within parentheses so it will be easy for us to identify our inside function or outside function. This number 3, hint, don't worry about that. Take it outside of the differentiation, okay? Focus on taking the derivative of this outside function natural log, inside function sine. Yeah, this is back with natural log, so we can use our formula for natural log, right? Hint here, hint. Derivative of the function natural log of x with respect to x is equal to 1 over x. Use this formula for this part. For the derivative of outside function, 3 is just a constant, okay? A very tricky question. Very long. Okay, since we are running out of time, let's do it together, okay? So we can complete this. Y prime, the derivative will be equal to what? 3 is a constant, comes outside. I'm gonna focus on the derivative of this. The derivative of this composite function is, following this formula, 1 over the inside of the log, sine square of 8x, right? 1 over that, times the derivative of this guy, right? Derivative of this inside function. Take the derivative of this carefully. 8x, allow me to write it this way. Great. Now, y prime should be equal to what? 3 times 1 is 3, divided by sine square of 8x. This is this part. This derivative. Notice that this is the derivative. Allow me to write it this way so you can see the composition. This is the derivative of sine of 8x. It's squared, right? It's squared. You see the composition now? This is the square function, the outsidemost function, right? And then inside this sine of 8x. So what is that derivative then? Well, y prime will be equal to 3 over sine square of 8x times derivative of this outside function, square function, is this twice, it's pointing here 1, sine of 8x, right? Multiplied by the derivative of sine 8x. And this is, guys, why they call this the chain rule, because you have to do it in a nested way, right? Yeah, so finally, right, putting everything together, the derivative of this part is just derivative of sine is cosine of 8x, right? But then I have to multiply it by the derivative of the inside function, 8x, whose derivative is 8, right? 8. So now is the time just to put everything together. Look, 8x here times this 3 over sine square of 8x, right? Yeah. Putting this all together, we're gonna get, I have sine of 8x here, sine of 8x squared here. One will cancel, one will stay, right? One will cancel, one will stay. So what will be left here? Well, this will be equal to y prime equal to what? Look, 3 times 2, 6. 6 times 8, 48, right? 48. One sine cancels, one sine stays. Cosine stays on the top. And remember, one of these guys stays on the bottom. Sine of 8x. 48 cosine over sine, I think, is equal to cotangent, right? Cotangent. So let's write cotangent of 8x. That's it, right? For you to remember where the cotangent came from, cotangent came from this division, right? So this is justifies this, okay? 48 times cotangent of 8x. And that is somewhere here. 48 cotangent of 8x, right? Very good. Okay, to finish, I think we should do this one. The last one, I think is 9. Is there more? No, yes, not 9 is the last one. So let's just do it together, okay? To finish with this. 9 f of x equal log base 6 of x to the 5th power plus 1, okay? Hint, this log base 6 of something is the outside function, and our inside function is this x to the 5th power plus 1. I'm going to give you the formula to take the derivative of a logarithmic function whose base is not necessarily e, meaning this log is not necessarily natural log. So this derivative is equal to this 1 over x, right? Just like the derivative of natural log, but it's not natural log. To compensate for that, just attach here natural log of b. Yeah, use this formula, guys. Try to figure this out. And we will finish with this. See? Yeah, there was another one. Very good. Number 9, Oscar, very good. Very good, Ruby. Very good, Adriana. Very good, guys. Very good. Excellent, excellent, right? What will be the derivative of this? Well, f prime of x will be equal to derivative of the outside function following this formula is going to be 1 over 1 over what is inside the log, which is this x to the 5th plus 1, right? It's called the argument of the log, multiplied by natural log of this base 6, right? This is the derivative of the outside function. Evaluated the inside function. CG also, very good, CG, very good, excellent. But it doesn't end there. You have to multiply this, according to the chain rule, by the derivative of this. Very carefully, dx here, with respect to it, right? But this derivative is easy to compute. Derivative of polynomials at this point should be something that you should naturally do, right? So this is just x to the 5th plus 1 multiplied by natural log of 6 times. Derivative of this 5 comes down, x stays with 1 less to the 4, right? Derivative of 1, 0. So this is it. And then just simplify this, right? That's it. 5x to the 4 power times 1 is 5x to the 4 power. And all this divided by x to the 5th power plus 1 multiplied by natural log of 6, right? This should be your answer. And this is somewhere here, I think it's here. Remember, right? Maybe I should do it. Mathematicians very often, when they present the final answer, the simple stuff, this constant function up front, the more complicated stuff, they push it to the right. So this will be x to the 5th. And this is what you will find among the multiple choices. So 5 plus 1. Yeah, and this is what it's in here, right? Yeah, exactly as it is there. Yeah, they place parentheses here. Yeah, very good. Okay, now I think there was one more here. This one I think is easy to solve, but we can just spend a few minutes. Let's just finish up with this. Log base 3 of 9x, right? And so use this formula, right? Recall the derivative of the natural log base b of x with respect to x is 1 over x multiplied by natural log of b, right? Use this formula, yeah. And together with the chain rule, right? This will be your outside function. And this will be your inside function. Very good, very good. Yeah, let's do it together, right? Yeah, go ahead. Very good, very good. Adriana, Ruby. Very good, guys. Very good, excellent, excellent, right? Yeah. Ruby, Adriana, CG, very good. Yeah, the derivative of the outside function should be simply 1 over whatever is the argument is a 9x here, right? In this case, multiply by natural log of this base 3, right? The base 3, this is the first part, times the derivative.
The base should be 5, sorry.
The base, thank you. It's this base is 5, thank you. Yeah, very good, yeah. 5 here, right? So this base should be 5, so this guy should be 5. Yeah, very good, guys are tuned. 5, right? Yeah, this is small. By the way, guys, when you take your exam in Blackboard, sometimes students say, Professor, sometimes the numbers are small, I cannot see well. There is always a way to make the symbols bigger using Control+. Control+ will make the symbols look bigger, Control- is smaller, right? So use that in case you don't see one. Yeah, times the derivative of the inside function is just 9, right? 9. The 9 cancels with the 9, and finally you get this. You get this 1 over x natural log of 5, right? Natural log of 5, which is this guy. Excellent. Very good, guys.